Every monsoon, the same scenes return to Kolkata. Busy roads disappear beneath water. Traffic slows to a crawl. Homes and businesses struggle with water entering streets and neighborhoods. Many people ask a simple question: why does Kolkata still suffer from waterlogging? Is it only because of heavy rainfall, or is the challenge much deeper? The truth is that Kolkata's drainage system is one of the oldest in India. Much of its underground network was designed for a very different city, a different climate, and a different pattern of rainfall. Today, climate change, rapid urbanization, and increasing paved surfaces are placing enormous pressure on that system. But around the world, cities are beginning to think differently. Instead of trying to remove every drop of rainwater as quickly as possible, engineers are asking another question. What if the city itself could absorb water like a sponge? Kolkata's drainage history dates back more than a century. The original underground drainage network was designed for the rainfall intensity and urban conditions of its time. Since then, the city has changed dramatically. Roads have widened, buildings have replaced open land, natural ponds have disappeared, concrete and asphalt now cover much of the ground. During intense rainfall, very little water can infiltrate into the soil. Instead, enormous volumes of stormwater rapidly enter the drainage system. When rainfall exceeds the drainage capacity, water begins to accumulate on roads and in low-lying neighborhoods. This is why waterlogging can occur even without river flooding. The challenge is no longer only drainage. It is urban hydrology. For decades, the engineering response to waterlogging was simple. Build larger drains, install bigger pumps, construct additional canals. These remain important tools. However, modern cities have learned that continuously increasing drain size is not always practical. Dense urban development leaves limited space for widening underground infrastructure. Construction often disrupts roads, utilities, businesses, and daily life. As rainfall patterns become more intense, relying solely on larger drains becomes increasingly difficult. The future of urban drainage therefore combines traditional engineering with smarter water management. Instead of moving every drop immediately, cities are learning to temporarily store, slow, infiltrate, and reuse stormwater. Replacing old underground pipelines in a crowded city can be expensive and highly disruptive. Imagine excavating major roads across Kolkata just to replace aging trunk sewers. Fortunately, engineers now have another option. This is known as trenchless technology. Instead of excavating entire roads, damaged underground pipelines can often be rehabilitated from within. Techniques such as cured-in-place pipe, CIPP, create a new structural lining inside an existing pipe. Similarly, glass-reinforced plastic, GRP systems, provide durable and corrosion-resistant solutions for large drainage infrastructure. These technologies reduce traffic disruption, minimize excavation, shorten construction time, and extend the life of critical drainage networks. For a densely populated city like Kolkata, trenchless rehabilitation represents one of the most practical engineering tools for upgrading aging infrastructure. The sponge city concept began as a new approach to urban water management. Instead of treating rainwater as waste, the city treats it as a valuable resource. The objective is to allow rainwater to remain within the urban landscape for longer periods. This can be achieved through several engineering and landscape measures. Permeable pavements allow water to seep into the ground instead of immediately flowing into drains. Rain gardens and bioswales temporarily collect runoff while filtering pollutants. Urban ponds and retention basins store excess stormwater during heavy rainfall. Green roofs reduce runoff from buildings. Together, these measures reduce peak stormwater flows and lessen the burden on conventional drainage systems. A sponge city does not replace engineering. It strengthens engineering by working with natural hydrological processes. The answer is yes, but it cannot happen overnight. Kolkata already possesses important natural assets, including the East Kolkata wetlands, which provide ecological support for the city's water system. Future urban planning can gradually integrate additional sponge city features. Redevelopment projects may include permeable surfaces. Public parks can function as temporary stormwater storage areas. Road reconstruction projects can incorporate bioswales and infiltration trenches. Urban lakes and canals can be restored as active components of flood management. Rather than replacing the existing drainage system, sponge city principles complement and strengthen it. Tomorrow's drainage systems will be smarter than today's. Rainfall sensors, real-time pumping station monitoring, digital drainage models, smart control gates, artificial intelligence. These technologies allow engineers to predict waterlogging before it occurs and operate drainage infrastructure more efficiently. The future city will not only react to storms, it will anticipate them. Kolkata has always lived with water. Its rivers, canals, wetlands, and drainage networks have shaped the city's history. The challenge today is not simply building larger drains. It is rethinking how cities coexist with rainfall. Perhaps the future does not belong to cities that fight water. Perhaps it belongs to cities that learn to live with it. A sponge city is not just an engineering concept. It is a new philosophy of urban resilience, where technology, infrastructure, and nature work together to create safer, more sustainable communities. Engineering Earth's Balance, Flowline Chronicles.